Today for your double, what we are going to look at in the first part of your double is looking at the present value of an annuity. And then for the second part of the double, going through and doing some, finishing off the questions on present value and future value and doing some past HSC type questions that involve just thinking about present value and future value, and going from there. So today we're going to understand what present value is, think about that common link between present value and compound interest, and then we're going to perform calculations with it from present value tables. So start off with, what is present value? All right, so the present value of an annuity, it's all about a comparison. It's all about starting to think about what is one single amount. So the one single amount that I can chuck into a bank account and then walk away from the bank account, that will match or equal the same as the future value for someone who's going and putting regular repayments into that account. So kind of just have this visual for here for you that, you know, the present value is over here, you know, and the present value is just that one repayment, not one repayment, but one contribution. I'm just going to the bank, putting one chunk of money in, and that one chunk of money, you know, it needs to equal the same as someone who puts in that regular contribution. So after month 1, after month 2, month 3, 4, 5, 6, however long that time frame is, you know, those two values at the end of that time frame are going to match, and that's what present value is. I want to pay it now to match what someone does when they pay it regularly. And that has some really handy benefits to think about, which we'll discuss in a couple of lessons time. So both investment schemes will grow to the same value in the same time. It's just different ways of how we put that money in the bank account in the first place. So just pulling these examples straight from that textbook, the Cambridge textbook. So let's jump straight into them and have a look at that. Before we go any further, take note that the table now has a different heading. So we need to be really careful that now when we're looking at these tables in our HSCs, paying attention to what heading are you? Are you the table I'm looking for? So part A says, what is the present value of an investment? That's $500 per month for 2 months at 24% per annum. So to do this question here, remember the first thing, this is our compounding. It's per month for 2 months. So that's okay. That's in months. But 24% per annum, that's in years. So what we need to do is divide that by 12. So that gets us 2% per month. Now, like we did with future values, we go to our table and we have 2% per month for 2 months. Our value that we're using is 1.94. So our table value is 1.94. So our present value, what we're going to get is that regular contribution, the $500, and we're just going to multiply it by that number in the table. So multiplied by 1.94, and when we evaluate that, we're going to get a result of $970. And what that means, when we go back up and look at this table, this image up here, if we invest $970 for 2 months, that would be the same as someone who put $500 in 1 month, and at the end of the next month put another $500 in. So that $970, this single payment here, will grow to the exact same amount as 2 lots of 500 will do over that 2 months. I hope that helped kind of explain it a little bit, and we'll just keep going. Question B, what is the present value of an investment that will match $7,000 per quarter for a year at 12% per annum when it's compounded quarterly. So here we have quarterly, so 1 year becomes 4 quarters. 12% when we divide it by 4 becomes 3% per quarter. So we're looking for the 4 and the 3. So the 3% column, 4 row, and we get that number 3.71. So our table from our value is 3.71. So our present value, same as before, it's now just 7,000 multiplied by 3.71. When we evaluate that, that's 25,970. So again, going back up to that visual picture, if we put $25,970 in to the bank and walk away from it in 1 year's time, or 4 quarters time, so 1 year's time, that is going to be the same as someone who every quarter goes and puts $7,000 into the bank at the exact same interest rate. All right, so those two are going to match each other, and that's that idea of present value. Watch what one amount matches this next lot. Okay, question C. Question C, oops, I skipped past it, is a little bit different. Question C says find, that payment or the contribution. So we're now looking at, in this question here, in C, we're looking at, well, what are these amounts going to be? How we, what was the investment going to be? So it's very similar. We're going to use this table again, but instead of multiplying the numbers from this table, we're going to divide. So 6% per annum compounded annually for 3 years. So just coming back down, 6% per annum annually, 3 years. Everything's already in those same units. So 6% per annum, we want the 3 years column. We're going to end up with that number 2.67. So our table value is 2.67. Now we know that the present value of an annuity is that regular contribution, that regular payment, multiplied by that number in the table. So again, because we're finding that unknown, that C, we're just going to divide 2.67 over across. So our regular contribution is just going to be 33,240 divided by 2.67. And when we put that on our calculator and we round our answers to 2 decimal places because it's money, that's 12,449. So again, going back up to this picture, we know that we had to invest whatever it was, 33,240, sorry. So this question was 33,240. What matched that? Well, that was that regular payment of 12,449 and 44. When we regularly made that payment, that was growing the same as that 33,000. Okay. Finally, question D. Find the payment and contribution, again, so very similar or identical to question C, of an annuity with present value of 10,000 and 8% compounded biannually for 1 year. So coming here, biannually means twice per year. So in 1 year, that becomes 2 periods. I've got to divide that by 2, so it's 4% per 6 months, if you want to think of it that way. So when we go back up to the table, we're going to get a value of 1.89 when we go to the 4% column in the 2 periods row, we're going to get a number of 1.89. So again, 10,000, we would have got that number from our regular contribution multiplied by 1.89. So now we're going to divide it by 1.89. And when we do that, we get a value of $5,291. And when we round that one to 2 decimal places, we get a 1 cent there. So this person would be paying $5,291 twice a year. And that would be the same as someone paying $10,000 start a year, walking away. All right. So what do I want you guys to do? Go to Cambridge textbook, exercise 7D, have a crack at those questions there. Once you've finished those questions, below the YouTube link that will be inserted into this OneNote, there'll be an attachment of some past HSC questions on the exact same thing, but those past HSC questions will be a mixture of future value and present value, so take your time with what you're reading there. And that's about it for this. Yeah, it's really important we get our heads around present value, and it's different from future value. And this idea that we've got that one investment matching lots and lots and lots of regular repayments. Because what we're going to look at in the future is how do home loans behave like annuities? How do the banks think about a home loan as an annuity with you? And if we can kind of get our heads around what present value is, it's going to make those questions easier. And superannuation, you can kind of hear that word annuity in superannuation, and they are literally an annuity. So we're going to look at questions that then have that more practical context. All right, guys, good luck with any of that. Any questions, please don't forget to email me and I'll answer as best I can. See you guys on Friday.